चलिए 1 second. अच्छा चलो लास्ट टाइम क्या किया था वी डिड हम वी वर डूइंग एक्सट्रैक्शन ऑफ अच्छा एक्सट्रैक्शन ऑफ मेटल्स राइट so we did I think we did complete the extraction of these unreactive metals. They were found in the native state, so you had to purify them. So you took the impure copper, put it at the anode. The battery would pull electrons out of it. It will turn into ions, copper ions. It will dissolve, and all the copper ions will get attracted to the cathode, which is the negative cathode, and where they would gain electrons, and they would gain electrons, and they would become copper back again. So you'll start getting a deposit of copper forming on the cathode. Okay, that was purification, and then you had yeah, if copper was found in some form of a compound, you will take that compound, you will dissolve it in acid, you will turn it into a solution, and then you will do electrolysis again. So copper would again be the one that will be attracted at cathode, will gain electrons, and it will become copper metal. Okay. So, and there was a third one, which was how do you get, if you have copper carbonate, you can heat it strongly so that it decomposes, forms copper oxide, and you can pass hydrogen gas over it, which is more reactive, so it will pull the oxygens out of it and become water, and copper would be produced. So that was the last method that we did. ठीक है? So this was, yeah, I guess that was it. I said the next thing that we're going to do is the reduction of oxides with carbon. And in the reactivity series, the reduction of oxides with carbon, this method, the method works for the middle metals, which is that if you look at the reactivity series, वो एक दफा फिर लिख लेते हैं Al carbon क्या होता है Zn Fe Sn Pb, then you have H फिर Cu Hg Ag Au Pt. अच्छा, these ones, the middle ones, ये these are the ones that can be extracted by reduction with carbon, because carbon is more reactive. ठीक है, carbon is more reactive. So what happens is carbon reduces it or displaces it. So for example, if I have an iron compound, which is like Fe2O3, carbon, remember we studied this, carbon is more reactive. In the reactivity series, carbon is over here and iron is over here. So carbon is more reactive. So carbon is going to displace it. It's going to reduce it. Carbon would steal the oxygens and form carbon dioxide. Carbon and oxygen, they form carbon dioxide. And iron gets displaced. All you need to do is you just need to balance it. If you want to balance the oxygens, there's 3 on one side, 2 on the other side. So I'm going to multiply this by 3. That by 2, this by 3. Iron would become 4 and carbon would become 3. So that's a balanced equation. Same with zinc. If I have zinc oxide, I reacted with carbon. Carbon is more reactive. Carbon is here and zinc is lower in the reactivity series. So again, what will happen is carbon is going to steal the oxygens and zinc is going to get knocked out, and you just need to balance the oxygen. So there'll be 2 oxygens and zinc would also become 2. So 2 oxygens, 2 zincs. ठीक है? So more reactive carbon displaces, or the other word is reduces, the less reactive metal. ठीक है, and carbon is basically acting as a reducing agent. अच्छा, is this clear? More reactive carbon displaces the less reactive metal. ये बात कहानियां clear है फातिमा, is this clear? Setup
Yes,
clear है?
sir.
अच्छा, that's it. Uh, Now there's one metal which you need to study in detail. Actually, you need to study zinc in detail as well, but iron in a lot more detail. So based on this, we're going to study the extraction of iron. That is the reduction with carbon. So this needs to be studied in, I mean, you're going to get big questions on this, and it has to be studied in a lot of detail. As a first thing, these middle ones, iron is moderately reactive, not too reactive. So what happens is over time, it will get oxidized by the oxygen that's in the air. So it will get oxidized by the atmosphere. So iron would react and form. अच्छा, हमारी bodies के अंदर भी ना, we've got I mean, hemoglobin has ions in it. So iron is like pretty common. Apples have iron, ठीक है, iron ions in it. So iron is like in a lot of places. As in iron salts are in a lot of places. Iron metal, you have to extract it. ठीक है, so iron is reactive. So normally you don't see iron. मतलब ये नहीं है कि आप जमीन खोदोगे अंदर से ना iron निकल आएगा, ठीक है. A lot of times what happens is iron would be in the form of compounds, ठीक है. It will be in the form of oxides, ठीक है. तो rocks वगैरह में it's going to have multiple oxidation states. Remember, it's a transition metal. Transition metals have variable oxidation states, so it can have a lot of charges. So some common iron ores जो है ना, so remember, iron is not going to be found as iron. So there's a rock which is called hematite, and that hematite contains iron oxide, Fe2O3. Either iron is 3 plus. And then there are other iron ores as well. ठीक है, limonite है. Hematite is सबसे important है. Actually, the most important one is hematite. Actually, that's a combination of, I think, FeO and Fe2O3. ये कितने हो गए? So total जो होगा ना, if you add them up, it's Fe3O4. So this one has iron 2 oxide and iron 3 oxide. You can remember it's got multiple oxidation state. It could be +2, it could be +3. फिर इसी तरह there are other ores as well. There's other ores में ना, there's एक और होता है, मैग्नेटाइट होता है, ठीक है. And paper में they'll give the names. If so, you don't have to remember all of them. The one that you got to remember is this one. अच्छा, लेकिन paper में a lot of times what happens is they give limonite as well or magnetite as well, but they'll write it if they give it. ठीक है. तो वो मेंशन होगा। अच्छा, उसके बाद ये कि so those are your iron ores, and remember the one that I'm more interested in is this one, Fe2O3. That's the red brown rust. I said these are basically rocks. So rocks होते हैं iron ores जिसमें there's a lot of sand and dust etc. बल्कि iron ore I'm going to show you iron ore के दिखा देते हैं कि what does iron ore look like? Just one second. तो जैसा rust होता है ना, it's a red brown. तो शेयर कैसा करें स्क्रीन, एक सेकेंड। हाँ, ये सामने ठीक है। So a lot of these red colored rocks, जैसा rust होता है ना, I mean, they're kind of like this. Zriniac actually, they're red in color, but a lot of them are kind of reddish in color. आपका जो blood होता है, it's reddish in color. Why? Because it's got iron 2 or iron 3 ions in it. So iron ores are like this, a lot of them. खैर एक सेकंड, वापस मैं स्क्रीन करूँ। I said, now how is iron extracted? It's extracted in a blast furnace. If you can see the screen, we're going to draw a blast furnace. So, as is the blast furnace, something like this. And so ये काफी है. Let's put it in the center. This is your blast furnace. I said, there are three things mixed in the blast furnace. 2, 3 raw materials are added from the top. The rocks are added, which is hematite, plus limestone is added. And there's another thing that's thrown from the top, and that's coke. Coke is basically a type of coal that's got a lot of carbon in it. Hematite is your Fe2O3, that's the red brown rocks that I showed you. And limestone is calcium carbonate. So 3 raw materials are added from the top to get into the blast furnace. Or the other kind, they're added from the top. There's one raw material that's blasted from the bottom. अच्छा, bottom के ऊपर ना इसको थोड़ा सा अच्छा, so bottom में ना there's going to be a pipe, and that's going to be blasting air through it. Okay, so and it's normally hot air that's hot air का मतलब it's oxygen gas that is blasted from the bottom. Okay, so that's happening. I say, anyways, the first reaction that happens is that heat gets produced. So right at the bottom, coke burns, which is carbon. It burns. Okay, oxygen is being pushed into the blast furnace. So the carbon reacts with oxygen, and it ends up producing carbon dioxide. Okay, so the coke that you're adding from the top, it burns, and it produces a lot of heat. So it's highly exothermic. heat is produced and your entire mixture melts. Basically, the coals that you added, the coke that you added, it catches fire. Slightly higher up, the CO2 produced reacts further with coke. तो यहाँ पे क्या होता है? The CO2 that is produced, it reacts further with coke and it ends up producing carbon monoxide. ठीक है, 2 molecules of. So it's got to be 2 molecules of carbon monoxide. Let's correct that. So the carbon dioxide rises because it's hot, and it reacts further with the coke again and produces carbon monoxide. Then over here, somewhere in the middle, both carbon, the coke, which is carbon, and carbon monoxide, they reduce hematite. You get reduce hematite. So carbon goes to Fe2O3. Carbon is more reactive. So it goes to the rock, which is now in molten state, steals all the oxygens, and Fe gets produced. And you can balance it. There's going to be 2, and there's going to be 3, and there's going to be 4 Fe's, and there's 3 carbons. Carbon monoxide does exactly the same. It also needs oxygen, so it goes to Fe2O3 and the rock, which is in molten state, steals all the oxygens and forms carbon dioxide. So if you balance this one, it's so got 3 oxygens and 2 Fe's. Yeah, now it's balanced. Okay. So that's your redox reaction happening. अच्छा, is this clear? मैंने यहाँ तक clear है सारों को नबीरा तहा बात में सारों को clear है शांत is this clear? तो अच्छा remember reaction करना क्या था? Reaction was simple, which was the reduction of iron oxide. You just wanted it to react with carbon, and carbon would steal the oxygens, and you'll be left with Fe. You just had to do that. Achha, but the whole process was that you added carbon, you added Fe2O3. Limestone, we're going to come back to it. You would start burning the carbon at the bottom, and it will start producing a lot of heat, and that will melt the mixture. So carbon monoxide and carbon dioxide will get produced. The carbon and carbon monoxide will then start reacting with the iron oxide. They'll start stealing the oxygens because they're more reactive, and iron will produce. Now, this iron that gets produced, it sinks to the bottom. Okay, so because remember, transition metals are heavy. So molten mixture में ना, because transition metals I told you were like 8 or 20 times heavier. So Fe is a transition metal, and they are all very heavy metals. And they sink to the bottom. So right at the bottom over here, right at the end, that's where you're going to start getting molten iron, because it's all going to sink at the bottom, right? So this is where you're going to get the molten iron, right at the bottom of the entire stuff. All the iron would eventually sink right to the bottom because it's too heavy. And then finally, why is limestone added? There's one thing extra that's added, and that's limestone. So limestone is added, and I'm going to write it over here. So limestone is added to remove acidic impurities, like because these are rocks that we are dealing with, so there's going to be a lot of sand. So acidic impurities like sand, which is SiO2. Okay, how is that removed? First thing, the calcium carbonate decomposes. So step number one is that it decomposes because of the very high temperatures. Carbonates normally tend to break down and they form calcium oxide plus carbon dioxide. Metal oxides are basic. So this calcium oxide will then react with sand, which is acidic. So you have a basic metal oxide and you have an acidic non-metal oxide. Remember this, metal oxides are basic, non-metal oxides are acidic, and they end up forming CaSiO3, which is called slag. So this one is called slag or uh, calcium silicate. Okay, so it's a compound. It's a sludge-like compound. It's a low density compound. And normally, what happens is that this slag it kind of starts floating on top of the molten iron. So low density slag is collected, which floats on top of molten iron, and is skimmed off. So and is skimmed का मतलब ऊपर से हटा देते हैं, skimmed off. The molten iron has a low density slag floating on top, and it's just simply skimmed off. ठीक है, so limestone का purpose of limestone is added to remove acidic impurities like sand, and there could be other acidic impurities as well, which are phosphorus oxides. You get that they could P2O5, yeah, P2O5, etc. I mean, other non-metal oxides, they could also be there. Like in sand is the number one. ठीक है, so the whole entire thing, this is it. ठीक है, the entire thing is को highlight कर लेते हैं. The top one, the purpose of limestone, it's added to remove the acidic impurities, ठीक है, that are there. ठीक है, and it decomposes, and then metal oxide, and so there's one acid-base reaction which is happening. There are two redox reactions. ठीक है, make sure you know that this one is an acid base. वो लिखा हुआ भी है, it's an acid-base reaction. There's a redox reaction happening, which is reduction of iron oxide. There's heat being produced, which is a highly exothermic reaction that's taking place at the bottom, ठीक है, where the coke is burning. So all these reactions you've got to remember exactly in the right order. ठीक है, वो अक्सर लेबल करने को भी कहता है कि मिडिल में क्या हो रहा है, बॉटम में क्या हो रहा है, what's happening at the top, right? So you should have some idea about in which part of the blast furnace what is happening. ठीक है, ये सारा clear है? Is this clear? ठीक है, अहमद हानिया फातिमा, is this clear? और ये कि ठीक और you remember this is something that's very important. You can get 10, 15. It's a question that comes very, very often. एक सेकेंड कि जो ब्लास्ट फर्नेस वाले क्वेश्चंस हैं इसको बल्कि पहले कंप्लीट कर लें तो बेहतर है एक इसमें ना there's one last thing which is the iron that you extract has one impurity that is still there. So iron obtained because you've added coke to it, not all the coke will react. So iron obtained has a lot of excess, ठीक है, excess extra carbon in it. And that's basically called pig iron or cast iron or wrought iron. So it's basically high carbon steel. Okay, which is basically an alloy. What you're getting is an alloy, not actually iron. What you're getting is iron with a lot of high percentage of carbon that's going to be in it, and that is steel. Okay, as I said, it's high carbon steel. The trouble with high carbon steel is that it's like really strong, but not flexible or malleable. Okay, so it's very strong, but not flexible, not malleable, not ductile. Alloys का ये होता है if you add a lot of impurities to it, so it's going to be not flexible and not very malleable or ductile. तुमने alloys किया था, you get a very irregular structure because of different sized atoms, because it's a mixture, and the ions cannot slip and slide. ये बल्कि alloys का हम अगर पीछे देखें ना, when we started off with metals, right at the beginning we did alloys, उसको revise भी कर लेते हैं कि this one, ये किधर गया alloys? Structure of a metal. अच्छा इसमें alloy नहीं किया था लेकिन alloys किए थे मेरे ख्याल से नहीं malleable and ductile किया था I'm just going to explain alloys once more. So basically you have pure iron, and in pure iron you have exactly the same size atoms, and they form a very neat and regular structure. ठीक है, all very neatly lined up, and therefore they can. So it's a lattice. It's a very regular, neat, and regular lattice of positive ions in a sea of mobile electrons. Metals like to lose electrons, so the electrons are buzzing around, freely moving around, delocalized, which means they can be anywhere. ठीक है, so between the gaps, the electrons are all. So they're all buzzing around. And the difference in an alloy is it's going to have high carbon content. ठीक है, so क्योंकि iron extract करने में we added too much carbon to it. So when you add too much carbon to it, तो क्या होता है? There are other carbon atoms which are now part of the structure. So let's say ये carbon है. That creates a kind of haphazard arrangement. इसको निकालो यहाँ से. Such as that kind of creates a haphazard arrangement. And because of that, the entire structure kind of has a very irregular arrangement. So let's say एक और carbon बीच में stuck है, and let's go. अच्छा, so what you're getting is a more haphazard arrangement. Is okay. And let's say there's अच्छा, anyways, so I'm getting maybe different kind of thing. अच्छा, basically this is what has happened. हाँ, ये तो जो तीन dots आ गए ना, these are basically carbon atoms. The whole structure has now become an irregular metallic lattice, right? So this is the structure of steel. The more carbon atoms that you have in the middle, because they've got different sizes, the more irregular the structure is going to be. So that's what an alloy looks like. So due to different size of atoms or ions, what happens is an irregular metallic lattice is formed. And the layers, because there are no layers anymore, so they can't slip and slide that easily. And metal ions can no longer slip and slide. They can't slip and slide easily. So that's alloys, ठीक है? तो आपको जो मिल रहा है ना इसमें, what you're getting is you're getting steel. You're not getting pure iron because there's a lot of unreacted carbon that's going to be inside it. ठीक है? This is what steel would look like. It's not going to be very malleable. It's not going to be very ductile. इसमें ये था कि if you apply a force or hammer it, the ions can easily sort of slip and slide, but not over there because if you put it over here, the wo jo layers are na, there are no layers. It's like completely haphazard. So it's harder to push the ions in between. The layers won't slip and slide anymore. So that's what an alloy is. This is high carbon steel. High carbon steel is like a pretty bad form of steel because it's very strong. But the problem with being strong is that it can crack easily. So there's going to be uh, this is normally kept for rough usage. For example, spade or wheelbarrow or gardening tools. Like well, for example, an axe would be made out of high carbon steel. Okay. Now the thing is, because it's got so much carbon in it, because blast furnace when you added carbon to it, you want to get rid of some of the carbon. So what happens is this high carbon steel is supposed to be converted to low carbon steel, which is known as mild steel. Here, that's known as mild steel. That is a more flexible form of steel. Well, if you want to make car bodies out of it, you want something that's more flexible, that can absorb impacts Uh, so oxygen is blown through it. So what will happen is oxygen is going to react with the extra carbon and it will form carbon dioxide, which will escape. So it's going to use up some of the extra carbon. So it removes the excess carbon. Okay. So mild steel is way more important because you make car bodies. It's more flexible. It's more malleable. It's more ductile. So क्या बनता है इससे car bodies, etc. Machines. Most things are made out of mild steel. Even a chair, even a bicycle. You want the bicycle to be flexible, not crack if it hits a rock. Okay. It can absorb the impact. चलो ठीक है कल कंटिन्यू करते हैं जैसे ये क्लियर है कोई क्वेश्चन नहीं है इस पे I'll share the notes with you. Just make sure the blast furnace has to be remembered. Every reaction of the blast furnace has to be remembered in exactly the same way. ठीक है ये मैं नोट्स एंड में शेयर कर देता हूँ ठीक है तो कल कंटिन्यू करते हैं ठीक है ओके
सर
एवरीवन
अल्लाह हाफिज।
टेक केयर अल्लाह हाफिज शायद मैं रिकॉर्डिंग भी सही शेयर कर देता हूँ ठीक है